Hey guys, welcome back to another video. I'm Akshansh and today we are going to have a walkthrough through this third assignment of day 3, basically first assignment of day 3. And yeah, so if you haven't yet watched my last video that talked about the assignment for day 2, please consider watching it or you won't be understanding what we are going to do today. So yeah, first of all, make sure to listen to this podcast episode by notebooklm and read this amazing white paper by them. And what you should do as a tip, I'm telling you, you should play this YouTube video in background, and with that, just read the white paper simultaneously. Just do both of them together and you'll understand the white paper way better that way. Yep. So now you can do all this if you want these, but yeah, if you are on day 3 it means you probably don't need these links. So let's open the day 3's assignment A, and just a second. And I've already did this assignment, that is why I'm seeing this edit my copy option. You'll see you'll see create a new copy. Oh sorry, create and edit. You'll see that option, create and edit. Okay, so now it's here, day 3. Okay, so yeah, in today's code lab we'll be understanding about memory management. So if you have watched my last video, you must be familiar with that problem statement that I told you, like when on the first day I was trying to access my agent, it didn't remember about the memory. But finally on third day we are finally going to see how we can implement this memory database features, so our agent will just remember our conversations and it will be better now. Okay, so yeah, let's just scroll down to here and go to add-ons, secrets. Okay, just let me just do one thing. I've ran this code. Let me just restart and clear all outputs, right? Okay, now it's fine. Yep. Now I should try to run this and go to add-ons. Okay, my Gemini key was there. You might have to set it up if you don't have it. And let's just run this. These import statements are just useless, you won't understand them. Let's skip it. Here we have our helper function, and helper functions are basically just meant for copy pasting. Basically, you don't have to understand this. uh, oh, let me just see if I can explain something here to you. Okay, so basically, yeah, you don't have to understand this helper function, like it just works, right? And okay, yeah, so our adks were imported, and now we can run the helper function defined. Nice. We can do retry configs to just tell our code to retry if any http errors occur. And section 2, session management. Okay, so I'll just explain to you what they're trying to say here. So basically the problem statement they give is that uh, basically we have large language models, like, right, so they are stateless, so they don't have any state, and they are really like, I how can I explain to you with a better analogy? Imagine your large language models, they are introverts. They are confined with their knowledge, their information, right? Basically, they don't have the latest information with them. And to solve this, we will be using sessions for short term memory and memories for long term memory. Okay, so session will be taught in this particular notebook, and for memory, we'll have to go to the 3B notebook. That is the second part of today's assignment. Yeah, so here they are basically telling you what a session is. You can read all of this if you want. I'll just explain it to you through this amazing diagram they have provided. So basically, imagine this is your agent. Okay, this is your agentic application. Now it will have many users, and one of the users is here. This user will have many sessions. Sessions are basically chats, many sessions, and this is just one of the session that we are going to see. And this session is going to have a lot of events and a lot of states. So states are basically key values, like some key and its value, like you can call it, is session a voice chat, and it could be true or false. That would refer we are talking through the voice configuration or not. So yeah, or does session contains image. So basically it would mean that user has sent some image as an input in this particular session. So that is why states are there. And events are basically inputs that you give to the agent, outputs that you give, outputs that you get, and image generation, video generation, it could be anything. And then we have here how 2.3, how to manage sessions. Okay, so first here, they we saw these session events, right, that are inside of sessions. So we will be exploring more about sessions now. And sessions basically come with two major ADK services. ADK is basically our agent development kit provided to us, and it basically comes with two of the major services. The first one is session service. Okay, what is a session service? Session service is basically our storage layer that would control all our database, and this runner is our orchestration layer. If you have attended day one's Codelab, then there they told this analogy in the white paper of day one, actually, that orchestration layer behaves like the brain of the AI agent. Okay, so it would basically manage the flow of information between user and agent. All right, basically all the functions that your brain does, orchestration layer does it for the agent. And there's analogy they have provided for this. You can read it, but I couldn't relate to it much. Try to read it if you are able to relate to it. It's up to you. And now we move to 2.4, implementing our first stateful agent. Okay, so now they're defining an app name. You can name it anything. Your first app, you can name it anything. I'll be leaving it to default. And here we have a user ID and session ID. Now just know this is basically demo code. In production, we would actually add a code here that would securely generate token for our users and sessions, so that some hacker cannot easily just access a user's session, right? We would have to make unique IDs for every user ID and session ID. So yeah, this is basically demo code. Don't do it in production level. For that, we have different packages like JWT, JSON Web Token, for those. And here we are defining our agent finally. That would be a text chatbot, right? And retry options or retry configs. Okay, so let's just run it, and let's go below, and we are now going to test our stateful agent, and we are providing it with two queries. First, we are going to tell the agent our name, I am Sam, and then we'll be asking it our name. Let's see what it does. And as you can see, it gave our name as output. That means it remembers the name, but this memory that we have stored, this is a session memory. If you just what you do, if you factory reset your Codelab and run this again, run all of this again, you wouldn't see the same output if you just ask it its name. It is a temporary storage, okay? It's not a permanent storage. They are giving the same, forgets the conversation. They're basically telling the same what I just explained to you. Restart the kernel and all. You can do it. It will take a lot of time if I just do this. So yeah, I don't want to increase the duration of the video. And now basically you don't have to run you can run this after restarting the kernel, but we are not doing it. You can do it if you have enough time. Now, as you can see, our problem statement arises that the conversation was there, but we cannot retrieve any information from our past conversations, right? Basically, this was our conversation in past, and we cannot anymore extract information from it. Like if you do this, it would give something else as an output. I'm sorry. So yeah, this is our problem statement, and we are going to discuss the solution here. So coming to section 3, persistent sessions with database session service. So you can see this table here. We were using in-memory session service earlier, and you can see it lost the data on restart, but database session services survives restarts, and they're used in small to medium apps. And oh sorry, never mind. And agent engine sessions are used in enterprise scale, basically large models. So we'll be most probably exploring just database session service for now. We are not building up enterprise scale agent right now. So yeah, just run this code cell, and we are basically defining our LLM agent container here, and a database URL that has to be unique for each of the application, and our database will be hosted here. Basically we are using SQLite, right? You can study more about SQLite. It's on Google. It's a basically type of database service provider. And yeah, we ran this. Now what we can do is test run 1 verifying persistence. Okay, so this is a session 1, test db session 1, and we are going to ask our name to it. Just a second. Yeah, so it did remember our name. Okay, and what you can do now is you can restart your whole kernel, but what you'll see now that it will remember our name, Sam. So that is the change that we have now. But do you think of this, like if a user asks about their name, they give it their name, don't you think name should be something that should be available throughout all the sessions of the service? But as you can see, if you just change the one to something like 2, and you ask it what is my name, if you do this, it just shouldn't work. I don't have access. But this shouldn't be the case, right? An agent should remember our name for all of its life if we tell it once, for all of its sessions actually. So yeah, this is a problem statement. We'll be exploring that later on. Let's verify session data is isolated. Okay, so we are basically accessing, oh yeah, they're just doing the same thing that I did earlier, that I was explaining to you. They just did the exact same thing. Okay, never mind. Yeah. So now we are going to see how our data is stored in the database. So you don't have to understand this code. This basically, they are fetching all the stuff that our database has and they are printing it. They are basically running a loop in our database, and as you can see, this is how content is stored in our database, right? And okay, so I have this stuff from my old runnings. You won't have this. You will probably have only these first lines. You can ignore this. This is basically I'm running this Codelab again. Yeah. And now we have section 4, that is context compaction. So context compaction is basically uh, like, for example, sometimes your list of events can grow so larger that your agent becomes slower, right? If events are larger, then as agent will be slower eventually. So what compaction does is it takes a big input, or it is basically output by the agent, but for our compaction service it's input, and that input again goes through the agent, and agent just summarizes it, so it can be faster next time. We'll see more about this in the day 3b code lab in the next one. And let's just create an app for our agent. And as you can see, now we are not configuring the LLM agent container, we are configuring the app container. Okay. And okay, one thing is that they're explaining compaction here only. Sorry, I'm sorry, they won't be doing in the next code lab. We are going to do it here only. Okay, I just forgot, I'm sorry. And compaction interval is basically a variable that after matlab, it's like after n iterations summarize everything that you have learned. After a particular number of inputs by the user, just summarize everything. I'm sorry. Yep. So let's just run this, and now yeah, I'll just explain this code to you. So basically what they mean here is, first turn will be running, second session will run, and third session will run, sorry, it will run, and after that all of the output that we are getting from here will get summarized by the context compilation, and we can access that summarized stuff here, like who are the main companies involved, and that will be summarized stuff for all these three outputs. So you can run it, and I have already ran this code lab, that is why I'm getting this error. You'll see a you should see a output here instead, right? It won't work for me, don't worry. And then we have our 4.3, that is verifying compaction in the session history. So the conversion above looks normal, but the history has been changed behind. How can we prove it? Okay, so basically they are trying to say here that our history has changed behind the scene. It has been compacted by our context compiler, but we don't yet know how to prove it, right? That's basically what they're trying to say here. So they just provide you with this code, and it will search for the compaction summary event, and if it doesn't find it, it will throw out this error, and if it does find it, it will do success. It will print out the user's name and everything. Let's just run it, and yep, as you can see, it worked. Author was the user, and here's the whole compilation, and you can see what you have accomplished in this code lab. It's basically useless. You can read all this, you can visit their documentation if you want. And now we have other problem also, that we do have our agent and everything set up, but we want to share it across the other sessions, right? Like username is something very common, and it should be accessible throughout all the sessions, right? We are going to just learn that now. I'm sorry. Yep. So first, username, scopes, river, these are basically state keys that we saw at the start of the notebook. And this is basically somewhat a helper function for us, and this basically is creating two states that are user is name, that will be user's name, and here as doc strings we are telling our agent that what user name would be, how you can extract it from the input, and then that username gets saved into a variable and here, and then it will be saved to the database or state, you can say it. And this is our another helper function, that is retrieve user info, that this will be basically dot get, right? We have saved it here, and we can run dot get to get it from the database. And yep, that's pretty much it, I guess. Let's run this agent that we just created, and we'll add our new tools here that are save user info, retrieve user info, where we'll be defining description here, that for say recording a username, do this, and if user is asking to tell asking to you his or her name, then just do retrieve user info tool, and the other tools, right? So we have our list of strings here, and we can just run this and see the demo session. As you can see, first, how are you doing today, what is my name? First it wasn't aware of its name, we told it, and now as you can see, it gave it as an output. And now we can also inspect the session state, like how it looks like in the database. As you can see, it looks like this: username Assam and user country Poland. That is basically this only. Username country and username name and user country, right? Okay, so we run this perfectly fine, and now coming to here, we can just run it, and I'll explain what they are trying to say here. Basically, they are trying to access the information in a new session, but you'll see a magic in the output that they weren't able to do it actually. So we'll be studying how to do this in the next code lab, of course. And you'll also see another magic here. If we try to get the session, right, you see new isolated session, when we were trying to access it like this, we didn't get the information. But what if we try to see what is stored in this new session thing? And if you run this Codelab, you'll actually see username and user country are stored here, but still they are not configured by the agent here. We'll learn in the next Codelab why this is happening and how to fix it, right? So yeah, you can just clean this up. Let me just do it and cleaned up all database files. You can read all this summary, all this congratulations and stuff, and you don't actually have to submit it. A lot of people were asking about this in the Discord server and in my DMs. You don't have to submit it. You can just close it and just leave. Oh, this is now let's open the second code lab for today. And edit my copy, you'll see a different text here. And yep, now we are here at part 2 memory, and we are going to learn about the long-term memory knowledge now. Session was a short-term memory that we did in the last code lab. We are going to explore the long-term memory. You can read this table if you want. There's just nothing to read here much about. You can read about the task if you want. I'll be straight out just running this. And well, yeah. Just a second. I ran this right. Let me just reset this code lab. Restart and clear outputs, right? Now if I run it, it should work eventually, right? And let's just set our ADKs to be there. Now as you can see, we are defining a run session helper function this time, and what this will do is it will run queries in a session and display the responses of those queries. Basically the queries will be in the form of an array, and that array will have a lot of strings that we had in our previous code. And we have a retry configure. Let's just okay, it ran. Let's configure the helper function, then retry config. Now moving on to the section 2 memory workflow. So just a second, let me just zoom it a little bit for me. Yeah, so first we are going to this is going to be a 3-step process. So the first process is basically initialization, and what it does is it creates a memory service and it sends itself to the agent through a runner that we learnt about in the last code lab. And in step 2, we use ingest to transfer session data to our memory using a function they are defining, add session to memory, through this helper function. And then we can, in the step 3, ask our agent whenever it wants to just access the memory services, okay, through search memory function. They are calling the function search memory. So this is the basic workflow. And yep, so section 3, initialize memory service. So we are going to initialize it first. You can just run this, and this is a built-in memory service by the ADK. You don't have to understand any of this code. Built-in code is not meant for understanding actually. So yeah, and we can add the memory to the agent now. Just a second. Yep. And next we have to create a runner actually now. Okay, and that we can do with this piece of code. And we have run this same code many times, like it's the fourth Codelab if we count day 2's both Codelab of day 2. So I am not going to explain all of this code again to you. And here's the important configuration versus usage. Adding memory service to runner makes memory ever. Okay, what is trying to say is memory service, when it is integrated with the runner, memory service is integrated with the runner here. They are not showing the runner in this diagram, but yeah, when it's integrated with the runner, it does make your memory available to your agent, but it isn't able to automatically use it. We have options. First is ingest data that we saw earlier, and second is enabling the retrieval. And we have two options for it: load memory or preload memory. Load memory is basically loading it when needed, but preloading is just loading it anyways. They will define the same here, you can read it if you want. And they tell about this production that we'll be learning on day 5. Yep, a long way to go. And now we have our in section 4 ingest data session into memory. Why should you transfer session data into memory? Okay, so now you have probably learned, I've told you many times that some data is just too common, for example a username, so you would need that in a long term recall, and that is why we are going to do this. You can read their paragraph if you want, I have already explained it. Okay, now, okay, so my we just told it our favorite color, right? And we'll probably be extracting it later on from it. And now we are going to do get session to get all this data that we saved here, and we are going to save it. First we'll see the output, how it looks, our response in the database. Yeah, so this is how our session looks in the database. And now we'll add session to memory. This is a built-in function. I'm sorry. Yep, now we can enable the memory retrieval in our agent finally. And this is the load memory and preload memory. I already explained it to you earlier. And yep, we can run it. We are going to use load memory for now. Okay, so we are only going to load when needed. If you need to, you can read the instructions that we provided. Use load memory tool if you need to recall the past conversations, right? Great. And now we can update the runner and test. Let's now update the runner to use a new user agent. Okay, so basically we are updating our runner now. And as you can see, we had a different session here. Our earlier session was different. If I can show that to you, just a second. It was conversation O1, but now it's a color test, right? But as you can see, it did work. So we have finally found a solution to our problem statement that we had in the last part of the last Codelab, right? And this is basically they are demonstrating the full cycle of the workflow here. Basically ingest first stores the data, and then later it can retrieve it whenever it wants. So basically we'll be storing our date of birthday here, and it remembers it. Then we can do get session, and we can add it to the session memory. So you can just remember all of this code that say first we run session, then we get session to get it, and then we add it to our memory. This is how the cycle works, and then we can access it anywhere else. As you can see, it works. And this is basically what I just explained to you now. And now they are giving this experimenting thing, so I can actually demonstrate this to you, but I am not going to do so. I want you to go to this Codelab and do this part on your own, because I cannot spoon feed everything to you. And this is a really great experiment that you can try out. So yeah, do this part on your own, please. I highly recommend you to do this. This is basically the preload memory, and they have everything written here. You won't have to do anything new. And then we have manual memory search as a 5.5. So basically this is telling here now we are going to learn how we can edit our memory and how we can build analytics based on that. For example, how many people like blue, how many people like red, like that, right? How we can implement statistics and analytics now. So basically the query is we are gonna search our memory with this query, and we'll get our response, right? As you can see, it searched and it found three relevant memories. The first one is of course the blue green one. The second is where the haiku where we were talking about it, and this third one is quite irrelevant. I don't know why it did that as an output, but yeah, your turn. You can test it with different stuff if you want. I'm not going to demonstrate this, do it on your own. And this is basically showing how search works. I have explained this to you already, and this part they will teach in day 5. Okay, so now section 6, automating memory storage. Okay, so as you can see, we were running this function here every time, add session to memory. What we are going to do now is something so that we don't have to run that function again and again. So basically they are telling about callbacks. You can read this whole thing, but I'll just explain it to you the code. One thing that you should must know is what callbacks are, and they are basically Python functions that you can keep calling it again and again, and you can attach them through to your agent. So for example, this is a callback. We have attached it to our agent, and our agent has these other callbacks also that are eventually attached to it as functions to make our work easier. Okay, and now we move to 6.2, automatic memory storage with callbacks. For automatic memory storage, we'll use after agent callback that we saw here. We'll be using it for automatic memory usage, and it will be triggered every time the agent finishes a turn, and then it will automatically call this add session to memory. Okay, so basically first before agent callback will retrieve everything, and after agent callback will store everything. That is how it's going to work. So let's just do it here. Let's just run this piece of code, and callback is created for us, and create an agent also. Now we are going to create our LLM agent with instructions that will be answer user question, and we are using auto save to memory, of course, the problem statement that we are going to solve. And what happens automatically is basically yeah, I just explained it to you above, so you can read it if you want. Now let's create a runner, and we are going to test it finally. And as you can see, I gifted a new toy to my nephew on his first birthday, and this is going to be autosave. That's wonderful. I hope your nephew enjoys it. And now we are in a different session, and let's see if it did work. Oh yeah, it did work. You gifted your nephew a new toy, right? It worked. So what happened here is, before session they stored it in the sorry, after session callback stored this information, and here the before session callback retrieved this information and gave it to you as output. And you can read this table if you want. I have explained this. And now we have memory consolidation here. Okay, this is something important. So what there's a limitation to the raw storage, like we have stored message response and every tool call as they're telling you here, but there's a big problem that agent will be utilizing a lot of tokens, right? That is why we need memory consolidation. Basically, just take all the important things and only store them. That will make our token usage lower. Like it will decrease significantly, right? So for example, this is a big sample session data, and they just consolidated to it to sample memory. So it is basically like context, but that was like temporary, like, right? We studied the context thing in the last code lab. That was temporary, but this is permanent. Okay. How, and here's, here they are basically explaining how it works. I just told you this. And yes, we are now, amazing thing, we are done with today's code lab. Yep, you can read this summary if you want. And yep, that's it. So today we learned two things. The first one was how you can access memory temporarily, and we had our problem statement that we have of course differentiation, and there are just some facts that we need to access everywhere. For that we had a second notebook, and in the second notebook also there is a problem that has arisen, that had arisen, that was sometimes we will just utilize a lot of tokens, and for that we had our consolidation of memory. So yep, that's it for today, and thank you for watching this video.